And now finally I have illustrated you how local and global variables work for a function. So now we will be moving to the next point, that is the arguments and the types of arguments in Python. So there are actually two types of arguments in Python, and those are positional arguments and keyword arguments. So what do I mean by positional argument? So by saying positional argument, I do mean that suppose I am not taking any kind of input from the user inside the function itself, but instead I am actually using two different parameters inside this function, and I am just printing the sum of these parameters directly using the print statement, and this is only my add function. So what will I do? I will simply ask the user for two numbers for input and print the output. And one more thing I actually want you to observe over here is that if I give a argument to this function in this way, then this number 90 will actually go to the first position and number 87 will actually go to the second position. Now, why I am telling you this is, assume that I actually had to take two different variables of two different types. That is, the first variable I want that is to be actually a string. So in that case, I will not be, I cannot actually use these two parameters inter, or I should say arguments interchangeably. So suppose I want the user to enter his name at first and his age later in the function calling. So one thing more that you want, that you should notice, is that this name should actually be a string and this age should actually be a integer. So if user actually tries to, you know, interchange these two positional arguments, that is, if user actually tries to input the age in this function calling, then he actually enters his name, then the output will actually be bit different. You can see in this case, name, you are, age, years old. So what if I actually try to run this program? You will see that this name, which was supposed to contain this string, will now contain 89, and this age, which was supposed to contain an integer, will now actually contain this string, that is the name. And let me just run this program and show you. You can see that it says 89, you are Vishesh years old, which is not what I wanted. So you just need to remember that the param that you should actually give arguments to a function when you are calling it in the same type and the same manner in which you have actually defined them inside these parentheses. And the reason is quite simple, because if you actually try to uh, just change the sequence of this these arguments and try to run the function, then you will see that the output has actually changed. You will not get the output which you supposed that you will get. So these are positional arguments. Now, what if I actually try to give these arguments in a different way? That is, what if I used this way of actually giving arguments? Now, this way is actually used to give arguments in any order. Yes, in any order. And this is known as keyword arguments, not positional arguments. These are keyword arguments, and the previous method that we implemented, this is known as positional argument because they are actually referring to the position directly and then directly implemented in the function. But in this case, when we are going to use these keywords that we have defined inside the function definition, in this case, these are known as keyword arguments, and they are, no matter how, in which order actually you will provide them to the function, your output would always come to be correct. And you can see over that it says wish you are at 10 years old. This is something that we have already expected from the previous program too, but actually did not come. So now, in continuation, we should also read that how we can actually take indefinite number of these arguments. So assume that there is a function that you have created, and in that function you don't know how many number of arguments that you might need, or you want simply that user should enter n number or n amount of data. Now suppose that you actually have to create a function which you want to accept a very large number of arguments, but those arguments are not actually fixed in number. That is, sometimes they can be 10 in number, sometimes they can 20 in number, sometimes they will be 19, sometimes they will be 9, sometimes they will be 5, and sometimes there might not be even a single argument. So in that case, we generally use this keyword argument. We generally use arguments with starting with a asterisk. Now, if I try to pass it like name, and then I try to print the name is, and simply name, then you will see that, let me just make it a f dot name function and comment this one out. Now, if I'm going to run this function, that is f dot name, and you can see that it says this name can accept any number of arguments, but up to now, none are actually given. So if I want to run this directly, you will see that it is showing me an empty parenthesis. But what if I actually enter two strings, that is this and mm, this? What will happen in this case? Which one do you think would actually be given to this name and it will be printed? So let's see. You can see that it actually takes this whole as a tuple and just simply gives these two values directly to this tuple. And what would have happened if I have actually given a single argument? Then in that case, it will show me something like that. You can see over here. So I don't want this para, I don't want this parenthesis to appear over here. So what can I do in that case? So let's see. So to access only the, or I should say to print only this string without this parenthesis, we actually will have to use the concept of indexing. Yes, you heard me right. We will actually use the concept of indexing. And now if I'm going to print this, you will see that parentheses have been removed. And in this case, if I'm going to give more than one argument, I can simply change the value of the index from this tuple, and the value you will see over here being printed in the terminal and the value that you will see over here that will be printed on the terminal will actually differ. Let me just clear the terminal and run this again. You can see that the value is now Ram, and if I change the index to 2, you will see that the value is now Raghu. So in this manner, we can actually ask a function to accept n number of arguments, that, and remember that these are all positional arguments. These are not keyword argument, and we will now be coming to the keyword argument only. But before, let me just give you another summary of this function. So we defined a function f underscore name, and we declared a parameter inside it, that is name parameter. And because we wanted to accept any number of parameters, that is we wanted to accept any number of values, that is arguments. Let me just re-explain it. That is, we defined a function f name and we declared a parameter name inside it, but we wanted to accept n number of names. We actually don't know how many names a user will actually enter. So we decided to use this approach of asking the user for n arguments. And you can see over here that when we call the function, we can actually pass n arguments to this parameter, and these arguments can actually be accessed by using the concept of indexing. And I hope you are already familiar with the concept of indexing by now, and this was whole how we can use this argument. Now we will be heading to the next point, that is we will now be actually accepting n number of keyword arguments. So to accept any random number of keyword arguments from the user, you just simply use this approach. That is, we use a double asterisk, and we define a, then we define the parameter, that is name, and then we will simply, let me just make it L name here. Then you will simply define the name of that parameter, and inside that parameter we will be printing the name, that is the L, the last, or the surname is name. So yes, you are correct if you are thinking that this will again be returning a tuple. So let me just call this function L name and try to pass it arguments. So how will we be actually passing arguments to this function this time? Will the method remain this? So the answer is no. We will actually have to pass arguments like this. And because there is nothing specified, we can actually use our own values and then assign those values the value of argument, and then we will simply use that argument over here to access that value. To understand what I am saying, you just need to keep watching the lecture and you will get it. So suppose I want to call that sir name is equal to Goet, which is my surname, and I want to use another surname, and I will assign it a value that is this. Now I actually want to print this surname, and will I be able to do it using this approach? So the answer is actually no. We will see a tuple of these values. So you can see that we are actually having a dictionary of these values instead of tuple. I'm sorry for using the word tuple because This is the case of keyword arguments, and keyword arguments are generally stored with the key value pairs in a dictionary. So you can see a dictionary containing the keys as well as the values. So how can we actually access this name, surname, Goeth? So to access it, you just need to do this, and then you need to say surname, and when you will print it, you will see that Goeth has appeared on the terminal. And if you just change the value, that is, you just place this key in the string, you will see that the surname has now changed. So this is how we use the keyword arguments, and this is how we accept the n number positional arguments for a function. Now we have seen how keyword arguments and positional arguments work in Python. We will now be taking a look at the return statement in Python. Suppose I have created a function that is multiply two numbers, that is mul function, and I will be taking two numbers as input from the user. And now instead of printing the multiplication output that this function will generate, I actually want to use that output directly into the other function. Suppose I am creating a chain of functions, and in that chain, uh, every function that is at the top of the chain will actually give the value after calculation to the next function that is in the chain, so that the next function can actually use that value and compute some additional values and return to the next functions that are succeeding that particular function in that chain. So in that case, I actually use a return statement. And remember that, like break and continue statement, everything that you are going to use after, or I should say, everything that you are going to code after this return statement will simply be ignored by the Python interpreter, because a return statement generally marks the end of a function. So I actually want to return number num into number 2. And what will happen if I call the mul function and I just give two arguments, that is 3 and 2, to the function? What will happen? Will you see anything on the terminal? So the answer is no. You won't see anything on the terminal. You can see over here, you won't see anything on the terminal. But if I try to print what this function returns, that is, if I try to print the return value of this function, you will see that it will return 6 on the terminal. Now, I don't know whether I should cover the return type of the function that is generally used like this, oh sorry, like this, and then like this. Now, what does this actually say? So, this says that this this output after computations would actually be a integer. That is, this hints the coder that the output would actually be a integer when this function will finish its computation. And for more deeper details, you can actually go to any website and search for this syntax, or either you can skip it at the beginner level. Because I just wanted you guys to know that something like this exists in Python. That is why I just covered this point, but we will not be using it. So now we have learned that functions are actually a reusable piece of code, and we can call a function n number of times so that we can use it without actually repeating the code that we have already written in the file. Now we will be moving ahead to recursion. So what are recursions? So a recursion is a function that calls itself inside its body. That is, so what do I mean? I do mean that we will define a function, and inside that function itself, we will call that function. That is, you can see if, let me just create a new file, that is recursion.py, and what I mean is that I created a function, and inside that function, I did some code, and then I called the function itself once again with some arguments. Yes, with some arguments this time, not parameters. I will provide the parameters if there are any parameters inside this function. This time I will be providing them with arguments. So uh, this type of function, this type, which calls itself inside the scope of this function itself, this type of function is known as a recursive function. That is a function that calls itself. And you need to be careful while using these recursive functions because, like loops, they can also fall into infinite traps. So here is an example of a simple recursive function. We will create a function hello, and we will print hello in this function, and then we will call this function inside this function itself, and we will be printing hello guys, and we will now be calling this function. So what will happen if I'm going to run this recursion? So one thing that you should notice is that I am calling a function, this hello word, this hello function inside this function itself, and there is no way that this recursion can terminate. So this is a simple example of a infinitely running recursion. And in Python, because of safety measures that Python implements automatically, we will generally exit such programs, but don't expect other languages to do so for you. For example, you will see that it says the previous line repeated 996 more times. So which line? So this line. You can see that we are actually having a terminal full of hello guys the instant we actually click to run this file. Can you see this much of hello guys? I am actually scrolling down. You can see that over here. So our terminal is filled with hello guys, and eventually the program or Python interrupts this this recursive call, and finally the program actually exits, and the Python interpreter gives an error that this is a recursion error and maximum recursions has already been exceeded. That is, the maximum depth a recursion can actually go has been exceeded by this function already. So Python decided to terminate it without going further so that your system may not get harmed. So this is an example of a recursive function in Python. Now that we have seen a recursive function, that is infinite recursive function, so now we have already seen how infinitely recursive code works and how dangerous it is. We will now be taking a look at some definitely recursive function. That is, those have some definite recursions, unlike infinite recursions. And we will simply be creating a recursion that will print numbers from 5 to 1 in reverse order. Now that we already know how return statement works, we can easily implement the recursions. So I will define a function and name it counting, and inside that I will use a parameter num that will be accepted from the user, And now I will define my base condition. Now, what is a base condition? So a base condition is that condition at which you tell the recursion to end. That is, if the recursion arrives at a particular condition, which in this case will be 0, then I want the recursion to end and I will use a return statement, because if function encounters this return statement, it will simply exit, and I will be printing this number num if the number is not equal to 0. And I also want the number to decrease by 1 as it passes a single iteration. Now if I call this counting function and assign the value 5 to this function, what will you see? So you can see that numbers from 5 to 1 are printed on the terminal, and these numbers are in the reverse order, that is the descending order. So how do this recursive function works? So the answer is here. First of all, we have defined a parameter and we assigned a value 5 to that parameter. In this recursive function, we have actually defined the base condition, and this base condition actually tells the interpreter where to end the recursion. This base condition tells where to end the recursion. And how we define it? We just define it by giving a certain condition and say that if you encounter a certain condition, which is this num equal to 0 in this case, then simply return the value. That is, break the function or exit the scope of this function and execute whatever you encounter after you actually exit this function. For example, if there was a print statement which contained function has now ended, I should say recursion has now ended instead. So if says recursion has now ended, you will see that after it prints 1, that is after it encounters 0, it will simply execute this statement. But what if this base condition, which is num equal to 0, is not true? Then in that case it will simply print the number, and in the next line you will see that I have the recursive call. So this is the recursive call, because in this line of code we are actually calling the function itself. You can see we are calling the function itself with a parameter in it. So this, I should not say parameter, with a argument in it, but you can see that since we are inside this function itself and there is no value given to this, we will still be calling it argument. And I am sorry that I actually taught you that this will be argument, but it still will be a parameter because there is no particular value assigned to this parameter and we are simply using the parameter itself with some modifications. So this will be a parameter, not a argument. And I am sorry for this mistake, and here is the correction. You can see over here. Now, coming back to the recursive call, if the recursion encounters that base condition is false, it will simply start execution of the statements that are there in the recursion after this base condition. It will first print the number, then it will encounter the recursive call. Inside that recursive call, we have actually decreased the number, this number, I should say this number, by 1, and then we have again this function running starting from here with a value 4 this time. Then it will again check if the value 0 is equal to 4, and since it is not, the base condition will become false and it will again print the number, and it will keep on calling itself until and unless it reaches a point where it will find out that this number has now become 0. So when this number becomes 0, it will simply compare it with 0 and it will find that base condition has now become true. And because this base condition is now true, this if statement's code will be simply executed. And since there is a return statement written inside this code, so we will simply exit the scope of this function and print what is outside the function after we have already called it. So let us run this. You can see that the recursion first occurred and then it ended successfully, and now we have seen the output of this print statement finally on the terminal, and this indicates that our recursion was successfully executed. And this was a simple example of how recursion works, illustrating how recursion works, how it works internally, and what are base conditions and recursive call in a function. So let us write down another program. We will be calculating the sum of first and natural numbers using recursion. Now, to some of the intelligent cases, there might be a question that which which approach is faster to solve a problem which is actually having some repetitions, a loop or a recursion. So the answer is a loop. A loop is actually faster than recursion in many cases, but in many cases the recursion approach is much better to solve. So let's begin. So we will be defining a function that is sum of n natural numbers, then we will write a parameter inside it, that is n. Now we will be providing this function with the base case, that is if the number num becomes equal to 0. In that case we want the function to terminate, that is we won't want it to add numbers after the number has become 0. And else if or else the number is not equal to 0, then we will simply want it to return n plus sum of um, num plus sum of n and n minus 1 inside it, that is num minus 1. Now if I'm going to run this program, that is sum n, and if I'm going to pass an argument that is 10, you will simply see the result in the terminal, and the result should be 55 because the sum of first 10 natural numbers is 55. And you can verify your answer using this formula, that is n into n plus 1, and this result should actually be divided by 2. So this is the formula for calculating the sum of first and natural numbers, and using this the answer should be 55 for n equals to 10. Let us run this piece of code. I think I did some mistake in the code. Let me just check that out. Yeah, that is in the base case. It should actually return 1 instead of not returning anything. I will explain in the code to you, and it is not returning anything because I have to print the output. So print the output, and now you should see 55 on the terminal. Let me just clear the terminal and run the piece of code again. Yes. So why the initial program failed was because it was not returning anything in case of 0. If I actually had returned something over here, that is if I would have returned 0 in this case, then the program would have actually worked correctly. You can see that it works correctly. And why do I actually have to return something in this case? So the answer is quite simple, because when this base condition becomes true, that is when the number becomes 0, if I won't enter or I won't actually return anything, then this recursive call for keep looking for something that is of integer type to add into this num integer, so that it can finally return something. But if I won't return something in the base case in this condition, then it will not find out that something to return, and the program will simply crash. So you can either use this base condition, or you can either use this base condition. Both of the conditions are correct in this case, but you cannot use this base condition, and the reason is because in that case your answer would always be one less than the number that should be the answer. So for your understanding, let these base condition be equal to 0, so that you can better grasp it. So we have now seen a program that we can actually use to print the sum of first n natural numbers. Now we will actually be seeing another program to calculate the factorial of a number. So let us begin by using the def keyword. Then we will declare a function that is factorial, and inside that function we will accept a argument that is now a parameter, that is num. And if this num is equal to 0, in that case we will simply return 1, else else we will simply multiply the num with the factorial of num minus 1. We can actually we should actually return this value so that there are no issues. And now if I'm going to print the value of factorial of this function, and I want to print the factorial of the number 3, which should be 6. So you can see that there is 6 in the terminal. And if I try to print the factorial 4, you will see that the number is 24, which is 6 into 4, that is 24. Now, some of you guys might be wondering how this factorial works. So, before explaining how the code of factorial works, let me just tell you how factorial works. Factorial is a case in mathematics in which we multiply the number by reducing the number itself by 1 each time. That is, first we will reduce the number by 1, then we will reduce the number by 2, then we will reduce the number by 3. And one thing that you need to observe is that we are simply doing this, then this. So what is this? We are actually having a number, then we are subtracting 1 from this number, the previous one, and then we are actually multiplying the number with this number itself, and the number is then again this number is then again used over here, and 1 is subtracted from this previous number, that is the number which is just ahead this number. And then in the next case, this number will be written, and we will subtract 1 from this number and multiply it in the whole series with the whole series until and unless this number becomes 1. So how will it look like? For example, let's say the factorial of 5. So factorial of 5 will be 4 into 3 into 2 into 1. Yes. And factorial of 4 will be like, so factorial is actually denoted using this this symbol, that is exclamation mark. And for factorial of 4, we can simply say it will be 4. One thing I missed over here is 5. So factorial of 5 would be 5 into 4 into 3 into 2 into 1. And for 4, it will be 4 into 3 into 2 into all the way to 1. And similarly, the factorial of 3 will be 3 into 2 into 1. And this is how factorials work. But did you observe something? This 5 factorial can be written like this. This is 5 into, that is multiplied with the factorial of 4, which is nothing but 4 into 3 into 2 into 1. So I can simply write 5 factorial is equal to nothing but 5 into 4 factorial. Similarly, I can write this 4 factorial is equal to 4 into the factorial of 3, and similarly this number 2. So there is a generalized conclusion, that is the factorial of any number num is actually equal to this number num multiplied by the factorial of num minus 1's factorial, as it can be clearly evaluated from this pattern. That is, the factorial of a number will be the number itself multiplied with the factorial of a number that is less than 1 from that number. So this is how factorial works. Now coming to this program, we have defined a function called factorial and given it a parameter num. One more thing that I want you to know is that in mathematics, the factorial of 0 is defined to be 1. Yes, the factorial of 0 is not 0, it is 1. And if you want a proof, you can actually watch class 12th or class 11th video in which you will find the proof for this factorial of 0. But for now, I just want you to believe that the factorial of 0 is 1. And if you don't want to believe me, you can even Google it or go to ChatGPT or any other AI and ask whether factorial of 0 is 1 or not. And if it is 1, then why is it 1? So now coming back to the function, we defined a base case that if the number becomes 0, then you need to return 1. Now what will actually happen is the number initially is not 0, it is 4. So this base condition becomes false and this else block would be executed. And in this else block, the code is that it should return the number into factorial of number minus 1. So it will keep the number over here and go to the function factorial minus 1. If you think in this manner, then no, you are actually wrong. Recursions don't work in this manner. Instead, what will happen is first it will actually check if the base condition has become true, and only then it will start execution of this return statement. That is, it will actually go to the all the way till it encounters this base condition, and then it will this value will become 1, and at that point of time this value would be 1. So this would be factorial of 0 and this would be 1. Then it will come back to the factorial of 2, and this value will store 2 and we will have factorial of 1. Then we will have 3 over here, then factorial of 2, and in the same manner we will have at last the number 4 over here and the factorial of 3 over here. So this is how this recursion is working. Now I know that for absolute beginner, the actual explanation of how a recursion works can be quite difficult, because this is how this function is actually implemented under the hood. But if it is quite difficult, then you can actually take it in the another manner. That is, if the base condition is false, then it will simply multiply the number with the factorial of the second number, and this factorial m minus 1 will eventually become factorial of num into num minus 1, and it will go all the way till it reaches this condition, which is the base condition, that is 0, and it will return 1 for that condition, and we will have our answer, that is the factorial of a number. Now, if you did not get it, there are no worries, because recursion is a quite cumber subtopic for some beginners, I would say, and it was a chaotic topic even for me. So if you did not get anything, there are no worries. With time, you will get how factorials work when you will be studying C programming. So this is the last example on recursion that we are taking, and I hope you would have at least got an idea how recursion work if you did not understand it, because recursions are actually a bit, I should not use the word difficult, but I should say they are a bit confusing for a absolute beginner to understand. You will actually understand them when you have some prior knowledge of how the code works internally, or I should use the term how the memory works internally. That is the stack memory, the heap memory, how they work internally. After knowing that, you will actually know how this recursion works. But still, if you want me to explain, I will create a miscellaneous topic video, that will be the last video, and in that video I will be covering all the concepts that I have skipped in the Python tutorials because of simplicity, and you will find all those topics over there. But I am not guaranteeing you that I will make such a video, but I will try to make that video. Now that we have actually covered recursions, we will be heading towards the next topic, that is oops, in the next lecture. So hello and welcome everyone. We are now going to create our new folder that will store the content of lecture 7, and in lecture 7 we will be beginning with object oriented programming system, that is oops. Now the concept of oops is actually quite very important, and I should say it is a lot and a lot used in modern programming days, because this concept of oops actually treats every entity inside your code as a real world entity with properties and some of the functions that those objects can actually implement. I know that up to now the oops concept would be a bit chaotic for you, would have been a bit chaotic for you, and because I know for absolute programmer it is quite difficult to relate things with oops. But as time passes, just trust me, you will be able to relate things through oops once you have learned some low level programming languages. But before you learn any low level programming language and start skipping Python, I would suggest you that do not do that. Instead, you should be continuing with what you are doing now. That is, so I will suggest you to not skip coding in Python and jumping onto C, because you will be confused and you won't understand anything much in those C lectures. And the reason is quite simple, because C is a programming language which is at, I would keep it at a middle level, although most of the people now say that it is a lower level language, but the truth is that it is a middle level language, not a lower, not a higher level language, because you can actually access the hardware using C. And since this is not a C tutorial, we will not be talking much about C, but the main point is that if you find any issue or any, I would say, any complexity that is disturbing your brain, this is the only phase where the actual learning has begun. And I won't want you to give up, because many people give up at this point of time and they never learn anything new. That is, they actually don't want to face the period of the hindrance and the period of havoc, and they simply want everything to move quite comfortably and easily, which is not actually quite possible in the journey of learning new things. So let us move to the object oriented programming system, because this is the topic that you will be actually using while we will be working in companies and in modern day software, because OOPS is actually the building block of everything in modern software. Yes, you heard me right. It is the modern building block. But before I introduce you to OOPS, let me just give you a background that before OOPS was actually introduced to programming, how we actually used to program. So we actually used to create program using the procedural programming techniques. So we actually used to create programs using the procedural programming technique. That is, we actually used to write each and every line of code n number of times if there were n entities in the code. But after object oriented programming was introduced, we actually had to write only a blueprint of the entire code, and that blueprint was used again and again to make different objects from it. I know that these words blueprint and objects and classes would have haunted you by now, because it was a complete black box, and I accept that it was a complete black box, but it won't be now.